And in this chapter, we will talk about modeling phase equilibrium for pure substances. Okay. In this chapter, we have 3 points we need to cover. We will start with talking about how can we calculate the vapor pressure, and then how we can use mathematical models to model phase equilibrium to find this vapor pressure in case of we can't use the equation that we will discuss in the first point of this chapter. And the last point is we will talk about the fugacity and how we can use fugacity in modeling phase equilibrium. So by end of this chapter, we should be able to recognize, apply phase equilibrium criterion, and how we can use either the equation that we already know, like Antoine equation, for example, to use or to calculate vapor pressure, or how we can use thermodynamic models in order to calculate vapor pressure. So in general, let me remind you of the whole objectives we have in this course since the last chapter we have. So in this course, we have like 8 objectives that each one of you should able to master by end of the course. So we started with the first chapter, chapter 1, in which we identify systems. If you remember, we talk about the open systems, closed systems, isolated system, what is meant by equilibrium, what is meant by forms of energy, static forms of energy, dynamic forms of energy, the difference between them, static forms, the energy stored within the system, dynamic forms, energy that can be transferred between system and surrounding. Then we explained or discussed how we can use like graphs, how we can use tables, how we can use appendix in order to find thermodynamic data, how also we can use equation of state. Then we started chapter 3, which we discussed the first law of thermodynamics for open and closed systems. Chapter 4, second law of also chapter 4, second law of thermodynamics, when we talk about entropy. We introduced entropy, how we can use entropy to end up with a universal statement, describe the second law of thermodynamics. Then starting from chapter 5, we start talking about different equipment like pumps, compressors, turbines. We have cycles, how we can analyze each of these equipment by defining what is called isentropic efficiency, or how we can analyze the whole cycle by defining thermal efficiency. So we start talking about this equipment, so we start talking about cycles, calculate efficiency. We used the equation of state, and we said how we can use the equation of state, what are the differences between them, how these equation of states have been developed. Okay, starting from the ideal gas equation of state, then we have van der Waal, what are the limitations of van der Waal, and why we have like new equations like Suave equation or Penn-Robinson equation. And this is the last thing that we need to cover in this chapter. We will focus about like phase equilibrium. What is the criterion that we will use to know or define the equilibrium state? In general, this chapter, this is how we can like classify this chapter. This chapter has 2 points. So the first one is vapor pressure estimation. We have some equations. We can use these equations directly to calculate vapor pressure. And vapor pressure, this is the pressure at which phase change will occur, okay? Or the pressure at which like phase equilibrium occurs. But if we can't have or we can't use any of these equations, then we need to like develop mathematical models, and these mathematical models we need to use in order to define what are the conditions at which phase equilibrium will exist. So similar to the previous chapters. Do you remember previous chapters? We have tables, we have appendix, so we usually use this appendix or these tables to get the data that we have. In case that we don't have available data, then we need to use like mathematical models. This is why we use the expansion rule, the triple product, the partial derivative rule, all of these rules we discussed in chapter 6. So this chapter have the same way. If you have like enough information that you can use any of these equations in order to calculate vapor pressure or in order to estimate the phase equilibrium conditions, then go for it. But if you don't have this available data, then the only solution we have that we need to make or use mathematical models, develop these models in order to know what are the conditions at which phase equilibrium will exist. And in this mathematical models, we have 4 steps. We will start with entropy. This is how we think. Okay, we know entropy well. We used entropy to define second law of thermodynamics. Then we will use entropy to define phase equilibrium. But we will have some limitations with using entropy. So we will discuss these limitations, and then we will go to the next step, which is using gaps-free energy. Gaps-free energy also have some limitations. Then from gaps-free energy, we will use something called chemical potential. and we will see how the chemical potential is different if we are dealing with pure substances or if you are dealing with mixtures. And the point related to mixtures, this will be the thermodynamics too. Okay, so all of this point, chemical potential for mixtures, this will be discussed in different course. But we will at least talk about chemical potential, how it's related to Gibbs free energy, and how they are related for pure substances, which is the main focus of this course. And then we will end up with talking about the pheogacity, which is the general criterion that we can use in order to describe phase equilibrium. Is it clear?